So the next topic is parallel and perpendicular lines. So for parallel and perpendicular lines, we know that if the two given lines are L1 and L2 and they are in the same direction, then gradient is actually giving us the direction, and we can say that for the two lines parallel to each other, we can say that the two lines parallel to each other, the gradient value needs to be the same. Therefore, the gradient m1 will be equal to m2. But if the two lines are such that they are perpendicular to each other, it's L1 and L2, they are perpendicular to each other, then they will be having two different values of their gradients. One can be m1 and the other can be m2. So for perpendicular lines, it's the product of the gradients m1 and m2 that should be equal to a negative 1. So this is the relationship for the gradients which we have when the two lines are perpendicular to each other. m1 times m2 equals negative 1. So let's do a question. Find the gradient of the line that is parallel and number 2 perpendicular to the lines with the given gradients. So we are supposed to find the gradient such that the lines are parallel to the line with the given gradient. So gradients are given here. There are 4 gradient values given in the question. And also we need to find the gradient so that the line is perpendicular to the given line. So let's say that for the first question, m equals 7 by 3. Parallel lines, the gradients are the same. Therefore, very easily we can say m equals a 7 by 3. For gradient as a negative 2 by 5, we know again gradient remains the same for the parallel line, therefore m equals 2 by 5. If the gradient is minus 1, again the gradient remains the same, which is a negative 1. If it is a 3 by 8, the gradient remains the same, which is a 3 by 8. Let's do it for the perpendicular case, where we know that the product of the gradients m1 into m2 will be equal to negative 1. So in this case, the given gradient was a 7 by 3. So I should know that the line perpendicular to this gradient line will be having the opposite sign, positive. The perpendicular will be having a negative sign, and then the inverse of 7 by 3, which is a 3 by 7. So I can very easily say that the gradient is a negative 3 by 7. If we do it by the formula, it's m1 into m2. So 7 by 3 into m2, which equals negative 1, and that also comes out to be a negative 3 by 7. Second question, gradient given was negative 2 by 5. Perpendicular line should be having the gradient with the opposite sign. So it's a positive, and then 5 by 2, the inverse of 2 by 5 is going to be a 5 by 2. So the perpendicular line will be having the gradient m2, which equals positive 5 by 2. We can also see it by substituting the gradient in the gradient equation, which is m1 into m2 equals negative 1. If the gradient is a negative 1, given gradient negative 1, perpendicular should be having the opposite sign, positive. The inverse of 1 remains a 1, therefore the gradient is positive 1 for the perpendicular line. Last case is when your m equals a 3 by 8. So the perpendicular line will be having the opposite sign, therefore a negative, and the inverse of 3 by 8, which is 8 by 3. So the gradient of the perpendicular is going to be negative 8 by 3 here. Let's do a word problem. The points P, Q, R, and S have coordinates as negative 5, 5, negative 2, negative 1, 1, 3, and negative 3, 1 respectively, show that PQ is perpendicular to RS. So we have to prove that the line PQ is perpendicular to the line RS. So again, we know that the product of the two gradients PQ and RS should be equal to negative 1. So we can very easily find the gradient of the line PQ, substituting the values for by Q minus YP divided by XQ minus XP. It equals negative 1 minus 5 divided by minus 2 minus minus 5. So this becomes a negative 6 by 3, which is a negative 2 here. To get the gradient of Rs, it's the difference ys minus yr divided by xs minus xr. So this becomes 1 minus 3 divided by minus 3 minus minus 1. Minus 2 divided by minus 4, and my gradient value comes out to be a 1 by 2. So I can see that the two products, that the two gradients, they are negative inverses of each other. One was a negative 2, the other is a 1 by 2, so that the product of the two gradients equals a minus 1. Therefore, PQ is perpendicular to RS, and it is shown. Let's do another question. The line joining points A, x comma 3, the x coordinate is unknown, and B, 2 comma minus 3 is perpendicular to BC. Where C is the point 10 comma 1, we are supposed to find the value of x. X, I have sketched the two lines, and I have to get the value of x. The two lines are perpendicular. I know their relationship. It should be the gradient of AB times the gradient of BC, which equals negative 1. So A was x comma 3, B was 2 comma minus 3, and C is 10 comma 1. I can get the gradient of AB by substituting the x and y values. So this becomes negative 3 minus 3 divided by 2 minus x. It's the gradient of AB times the gradient of BC. Again, substituting the values, it's 1 minus minus 3 divided by 10 minus 2, and this should be equal to negative 1. So solving it, it becomes negative 6 divided by 2 minus x times 1 plus 3, which gives me a 4 divided by 10 minus 2, which is an 8. Simplifying it, I will get 3 divided by 2 minus x, which equals 1, and then further doing the simplification, I will get the x value, which comes out to be a negative 1 here. Now the next question, the diagram shows triangle ABC. The coordinates of A, B, and C are 0, 3, negative 4, negative 5, and a 6, negative 1. So with these three coordinates, they are saying M is the midpoint of AB and N is the midpoint of AC, and we have to show that MN is parallel to BC. MN parallel to BC, we know the relationship. It should be the two gradients that should be equal to each other because their direction is the same. So we can very easily get the gradient of BC. B is negative 4, negative 5. C is 6, negative 1. So just substitute the values. Gradient of BC will be equal to the difference between their y values with their divided by the corresponding difference in their x values. So here I can say it's a negative 1 minus minus 5 divided by 6 minus minus 4, which will give me a negative 1 plus 5 divided by 6 plus 4, that is 4 by 10, and the answer is going to be a 2 by 5. So I know the gradient of BC is a 2 by 5. It's only that if the gradient of MN also comes out to be 2 by 5, then the two lines are parallel to each other. So to find the gradient of M and N, M and N values are not given, but I know that M is the midpoint of AB and N is the midpoint of AC. So applying the midpoint formula, I can get the coordinates for M, and applying the midpoint formula for A and C, I will get the midpoint of N here. So doing that, midpoint of AB will be equal to M, and that is going to be XA plus XB divided by 2 and YA plus YB divided by 2. A was 0, 3, B was negative 4, negative 5. Substituting the values, I am getting the midpoint M as negative 2, negative 1. In the same manner, I will be finding the midpoint of n. It should be the midpoints for a and c. Therefore, it's going to be xa plus xc divided by 2 and ya plus yc divided by 2. We know the a coordinates, we know the c coordinates. Substituting them, solving them, I'm going to get the n coordinates as 3, 1. So I have the coordinates of m as -2, -1. I have the coordinates of n as 3, 1. I'm just applying them in the gradient formula, which is yn minus ym divided by xn minus xm. So this becomes 1 minus minus 1 divided by 3 minus minus 2. So that will give me a 2 by 5. So earlier we found the gradient of BC, which was a 2 by 5. The gradient of MN also comes out to be a 2 by 5, and I can very well say that BC is parallel to MN, and it is shown to us.